Okay, in addition to the other video that I'm going to send you a link for, which kind of goes over the high levels of bonding, this one should cover some of the things I probably get asked the most about, which is Lewis dot structures, formula writing, and naming. Okay, so I'm going to start with Lewis dot structures. First and foremost, when you are drawing a Lewis dot structure, you've got to decide if you're drawing it for an atom, an ion, a covalent molecule, or an ionic molecule. Okay, so we'll do atom, ion, I'll do ionic, and then covalent. Okay, if it's an atom, it's really, really easy. So for example, if you're going to draw it for fluorine, fluorine is an element. You look up its symbol, make sure you look them up because some of you don't know them yet, and then you look up its valence electrons. On the periodic table, it says that fluorine's electron configuration is 2-7. Its valence electrons is that number 7. Okay, so how do you draw the dot diagram for it? You're going to go like this. 1, 2, 3, 4, 5, 6, 7. I'm only drawing 7. I only care about the outermost shell because that's where the chemistry happens. And I just kind of go around in a circle. So I have 7 dots around fluorine. That's all you have to do for a fluorine atom. For a fluorine ion, there are a few things change. You have to then look up the oxidation state, okay? And in this case, fluorine's oxidation state, it forms a fluorine -1 ion. And that -1 means that its overall charge is negative. So what that means is that it's going to gain an electron. So instead of it having 7 valence electrons, 1, 2, 3, 4, 5, 6, 7, it's going to have 1 extra, which it's going to get from another element. But we don't care what that element is because I just want to see the fluorine ion. So there's that extra dot that's in the pinkish color, okay? That's what's different, is that you have a different number of dots, and it's going to be determined by the oxidation state, which you can also find in your periodic table. Then, because you want to communicate to me, hey, I know that this is an ion, you put it in brackets. So brackets indicate ion, and then you put its oxidation state or its charge in the upper corner. So that is how you would draw the fluorine ion. If you were drawing it for a non-metal, for a metal, because fluorine is a non-metal, you would say, let's do something like magnesium. Magnesium, its electron configuration is 2,8-2, so its number of valence electrons is 2. So I'm only going to put 2 dots around it. I don't care really in this case where they are. Then when magnesium forms a ion, it forms an Mg2 plus ion. That means it loses 2 valence electrons. Okay, so what's going to happen here is the 2 dots that I drew are going to go away. I'm not going to have them. And that right there, this guy is not actually a dot. It's a stray mark. There we go. So it's going to have none of those. And then to say, hey, this is an ion, there's the charge, which I got from my periodic table, and there's the brackets. Then, if you're drawing an ionic compound, you have to draw what's actually happening. And we know that things don't share. Electrons are actually transferred in an ionic compound. So let's use these 2 ions that we just had. If we were to draw the ionic compound of we were to draw the Lewis structure or the dot diagram of magnesium fluoride, that's MgF2. And on the next slide, I'll show you how to know that that's the formula. But most likely, I'll give you the actual formula. That means I need 1 magnesium and 2 fluorines. Well, since it's an ionic compound, okay, a metal and a non-metal, that's how I know it's ionic. What I need to do is I need to draw the respective ions that I need. So I need 1 magnesium ion, which we said has no valence electrons and a charge of 2 plus. And then because of this 2, I need 2 fluorine ions. So fluorine has 1, 2, 3, 4, 5, 6, 7, 8 dots, a charge of -1, and then another one. This is the ionic substance, magnesium fluoride. 1 magnesium, 2 fluorines. My charges on top should equal 0. So +2 plus -1 plus -1 gives 0, which matches. That's how you draw a Lewis dot structure for an ionic compound. For a covalent compound, it's really important that you count your valence electrons. So, for example, for water, water is an easy one, but you have to figure out how many dots you can draw. How do you know your valence electrons? Use your periodic table. So oxygen has 6, hydrogen has 1, and I have 2 hydrogens. So my total number of valence electrons is 8. I look at this and I say, okay, who's in the center? The atom that's probably in the center is oxygen. And oxygen has 6 valence electrons. So I'm going to go 1, 2, 3, 4, 5, 6. I'm going to highly, highly suggest that when you put your dots around that central atom, that you spread them out like that, because when you do that, it's going to give you the proper shape. Whereas if you were to just put the unpaired electrons far away from each other, you might get confused and think this is linear, when really it's a bent shape. Then I'm going to draw my hydrogens. I don't need to see them in different colors, but I'm going to show them to you in different colors so that you can see it. There are my 2 bonds. You don't have to circle the bonds, okay? I have 8 valence electrons. I have 8 electrons to work with, and I drew 8 dots. So that's how you do Lewis structures. Writing formulas is really not as hard as it seems, okay? You just have to make sure you're asking yourself the right questions for every single time that you do it. Okay? First question you ask yourself, is it ionic or covalent? Okay? If it's ionic, we'll go through that. There's a few more questions you have to ask yourself. If it's covalent, you're going to use prefixes, which you have to memorize, to indicate how many. Oh, I'm doing naming. I'm sorry. No, I'm not. I can do formulas this way. The prefixes in a covalent compound are going to be given to you in the name, okay? It's going to be something like dihydrogen monoxide. Di means 2, so I have H2. Mono means 1, O. Okay? So covalent, you're going to use prefixes. You'll see the prefixes. Don't switch anything, okay? The switching comes in ionic. So if you said yes, it's ionic, then you need to keep going and ask yourself another question. Your next question is, let's see. Does anything match table E? Usually things on table E are going to end in ate or ite, okay? You have a couple exceptions to that, which is ammonium and hydroxide. Okay? But those two don't end in ate or ite. But if it ends in ate or ite, it's probably on table E. If it's on table E, you look up the formula. And the oxidation state, which is on table E, and put it in parentheses. So, for example, if we were looking up sulfite, okay, if the name I gave you had sulfite in it, I would look it up on, because it ends in ite, I would look it up on table E, and I would say, oh, it's SO3, in parentheses, 2 minus. And I would get that all from table E. The next one is there a Roman numeral? Okay. Is there a Roman numeral? Roman numerals make your life so much easier. You don't have to look up the oxidation state. Okay. So in this case, that's the oxidation state. So if I told you that it is, let's say, iron 3 chloride, you know that iron is +3. This 3 goes with iron. It does not mean there's 3 irons. It means that the oxidation state of iron is +3. Now, you need to look up the oxidation states of each element that you're doing, and I'll continue with this iron 3 chloride, and then I'll do another example, okay? So iron, I don't have to look up iron's oxidation state because I'm giving it to you. So iron's +3. And chloride, the I just means it's bonded, and chlor is the root for chlorine. When you're doing a non-metal, you take the top oxidation state. When you're doing a metal, I have to tell you which one to use. So chlorine's top oxidation state is -1. Then, to write the formula, you're going to take the 3, put it here, take the 1 and put it here. You cannot have a -1 iron. You can't have -1 of anything. So you've got to drop the signs, okay? And then what happens is you have FeCl3, and that's your proper formula, okay? Now, another example that might be a little bit more confusing is, let's do magnesium sulfide. Because this ends in "ide," I know it's not on table E, and I know this is ionic, okay? There's no Roman numeral, so I've got to look up magnesium. Magnesium's only oxidation state's +2. Sulfur's top oxidation state is -2. So when I flip-flop them and I take the 2's, and I put them here and here, I have Mg2S2. Now, when you're doing ionic, when you're in this area here, if you can reduce it, you need to, okay? So 2 to 2 is a 1-to-1 ratio, okay? So you can put it in lowest terms. This becomes MgS. That's how you're going to write formulas. The only time you crisscross anything is in ionic. In covalent, if I'm telling you how many there are, believe me, don't make it that much harder. Finally, naming, okay? Naming, you're going to have the similar situation where you've got to ask yourself some questions, and they're kind of backwards of what we just did. First thing is ionic or covalent. And if it's covalent, you're going to use prefixes to tell me how many of each there are. Okay, so if I had N3O5, this becomes trinitrogen pentoxide. They end in "ide." Make sure you change that ending to "ide" because that means that it's bonded, okay? It's not trinitrogen pentoxygen, okay? It's trinitrogen pentoxide. Now, if it's ionic, okay, what you're going to do is you're going to, do you have 3 or more elements? If so, you need to look at table E and get the name from table E. Because if you have 3 or more elements, something's going to be on table E. You've got a polyatomic ion there. Then, what you're going to do is you're going to check the metal. Does the metal have multiple oxidation states? If so, then you need a Roman numeral. Which one is it using? Okay, there's a couple ways to tell that, and I'll show you a few of them. Usually you can just reverse the flip-flop, but remember that compounds are neutral, so the pluses and minuses have to cancel out. Finally, when you're writing the name here of an ionic compound, you need to name the metal, Roman numeral if needed, and then name the nonmetal, ending in "ide," or write your polyatomic ion. If you have one, okay? So in the case of, let's come up with a good one, PbCl2. So I name the metal, which is lead. My Roman numeral if needed. Okay, well I know this is ionic because it's a metal and a nonmetal. I don't have 3 or more elements, so I have nothing on table E. My metal has an oxidation state of +2 or +4. Because it has 2 options, I do need a Roman numeral. Which one is it using? Well, in this case, chlorine, its oxidation state is -1. Okay, I have 2 of them. So my overall charge from chlorine is -2. So lead has got to be using +2 in order for this all to cancel out. I could just take this 2 and put it up here, take this 1 and put it up here, and that matches. So my Roman numeral is going to be 2. Then I take the name of the nonmetal, but I change the ending to "ide," which would be chloride. Okay, that's how I name something that's ionic and the metal has multiple oxidation states. If it wasn't chloride, for example, let's say, we'll stick with lead, why not? It was nitrate. This is still lead too, because nitrate has an oxidation state of -1, and I have 2 of them. But I'm not going to change the name of this because it's going to stay nitrate. I don't change the name of things from my polyatomic ions chart for my table E. Hopefully that helps. Email me if you have any questions.